On page 2 of this packet, so the back of the front side, we are going to do number 4A together. Now, hopefully you've already done 4A, so this is going to be some sort of review for all of you. Where's your answer? Oh, yeah, here. Where's your units? Units, units, units. So how do we set up this problem? Most of you have already done this, so this should be a pretty easy answer. How do you start this problem? Step 1 is balancing, right? So how do we balance this equation?
1, 5, 6, 4. No. I got 1, 5, 6, 4.
6, 4? You sure, Keegan?
3, 4.
4, then you total up the oxygen, you end up with 10 oxygen, so you got to do a 5 here. As we go into these problems where we have chemical equations, reactions as part of them, remember, you cannot get past step 1 without a balanced equation. If this equation is not balanced, what will not be right in your T-charts? Yeah, what does this rely? Your mole ratio relies on a balanced chemical equation. So let's play make-believe that we got to a balanced chemical equation, and then our T-chart for letter A, how many moles of oxygen react with 11 moles of C3H8? So you set up your T-chart. Moles copies down. Now we have moles of C3H8 to moles of oxygen. What is our mole ratio here?
5 to 1. 1 to 5.
Then we just do the math. So now I want you to go into your notebook, your notes. Start a new heading. Doesn't necessarily have to be a new page. This will be a short snippet of notes. But we're going to call this section of notes moles to mass. And we are going to start with this. So write moles to mass, or moles dash mass, in your notebook, and then go ahead and write this formula, this equation, and then also this first problem. Now, you will find this problem in the worksheet packet, but we are going to do this here together and do it in your notes so that on Friday when you turn in this worksheet packet, you still will have an example of moles to mass. Also, while we're talking about the rest of this week, I should probably also mention that there is a quiz on Wednesday. The quiz basically covers everything from page 1 through page 6 in the worksheet packet. 1 through 6. That is for Wednesday. So here we have a moles to mass problem. What do you fundamentally notice is different about this particular question, question B, from what we've been doing on the front and back side here? Grams. There is grams added in here. How many grams of aluminum chloride will be produced if 2.5 moles of aluminum react? So what's the first thing we have to do? Balance this equation. That looks right to me. So now our mole ratio is correct should we need it in this problem. So let's get a T-chart started. Let's put on the line what we're given. So as we do What can we immediately copy down without even thinking about it? Moles of Al. And now here is the fundamental spot where we need to think about our journey to get to where we're trying to go. I've used Florida in the past. With spring break on the horizon, it seems only fitting. This is where we need to start making some decisions. And again, to this point, you guys have learned a lot of different things that a mole as a unit can be equal to, right? We've talked about things like molar mass, things like Avogadro's number of particles, most recently mole ratio, where you can compare moles to moles in an equation. So in this case, we need to decide where we want to go next. And we need to keep in mind where we're trying to get to. So where do we want to go next in this problem, do you think?
Moles, AlCl3.
Okay, now I have a grams and I have a moles. One of you is right. Now we need to get to grams eventually, right? But right now we have a conversion. We could do this, right? Do we need to here? No, because we're not asking about moles or grams of aluminum. We're trying to get to grams of something else. So this step is where we want to do what? Moles to moles of something else. This is our mole ratio step. This is where we want to switch substances in our T-chart. Because we want to get to aluminum chloride. This is where we can do this, where we can use our mole ratio in an equation. We can do that in this step. And now what's our next step? Now that we have these units, we can look at our mole ratio and fill in these numbers, right? So 2 to 2.
Can we just put 1 to 1, or do you want to?
No, I would put 2 to 2. I would not skip that step. I would not reduce this ratio. And your calculator is going to figure it out eventually anyway, so just let your calculator do the work. So now what do we copy down?
Mole AlCl3.
And then now, do we have a conversion to go from moles of something to grams of something? Yes. How do we do that, though? Yeah, that's fine. Okay, we can, but how would we actually do this math?
1 to 1.
Nope. What do we need up here? Molar mass, right? How do we calculate molar mass of something?
Find the weight of everything.
CL3 times 27 times
How do you know
5.5. Multiply this out, add it all up, you get 133.5 grams per mole. So now you have this. And now it's simply work for your calculator. So I want to point out the importance here of this step. We've kind of been doing it automatically the last couple days in class. We've just been converting from moles of one thing to moles of another. We did this in the lab. We did this in the worksheet from last Thursday, where we've just been talking about, hey, you can go from moles of one thing to moles of another. So that hasn't changed. But that has to be at the heart of your T-chart somewhere when you are asking a question that starts with one thing and converts to another. That's where you need this kind of step somewhere in the middle. And again, that is going to rely on a balanced chemical equation up at the top of it. That's just how all this has to work. And it's important as you go through these problems to look at and think about, where am I starting? Where do I want to get to? What are the different conversions that are available to me in my toolkit of sorts? Right? What can I do to get from, in this case, moles of aluminum to grams of aluminum chloride. That's the journey of these T-charts. And once again, they will get longer as we keep going. Where you kind of, just like if you were converting from miles to kilometers of something, it's not that easy. You got to go to miles, then to feet, then to inches, then to centimeters, then to meters, and finally to kilometers. Same kind of thing here. These T-charts become their own kind of journey, and you need to fill in all these spots in between with conversions that you know of.